Let us evaluate this integral as an example of a line integral. Now, it says you should evaluate the integral of, integral of x plus 3y with respect to x plus 3y dx, from a at 0, 1 to b at 2, 5 along the curve y equal x squared plus 1. Okay. Now, let's look at this. X squared plus 1. If you have your x and y axis, x squared plus 1 would pass through 1 and look something like this. Going from 0, 1, from here, along the curve, and reaching 2, 5. 2 squared is 4, 4 plus 1 is 5, right? So that is the case here. So we're going from here to here. All right. Now it's a line integral. And the general formula for it would be the integral. Well, let me put AB here. It's the integral, but I could very well also have put C. I know that it is already from A to B, I know the coordinates, so I could put C here. So this, generally, the integral along a curve C is equal to P dx plus Q dy, where P is a function and that takes place in the x direction, and Q is another function taking place in the y direction. So the dx is changing x, so it goes left and right. Dy is a change in y, so it goes up and down. All right. However, looking at this, it only has dx. So if you look at it, it can be written as integral along a curve of x plus 3y dx plus 0 dy. So it doesn't have any y components. It goes straight across in terms of the integral from 0, 1 to 2, 5. The y component in this case is 0. All right. Now, you see the fact that there is a y there. You're integrating with respect to x, but there's a y here. And you're supposed to get a number. So it's not like you're going to get a number times y. You have to do something about this y. So let us see. It says y equals x squared plus 1. So y is equal to x squared plus 1. So what you do? This y is the same as this y. But it's the same thing as this. So you could substitute x squared plus 1 for y. Alright? So you see that. Now, if you do that, you would be integrating along a curve of x plus 3 times x squared plus 1. Nice. And it is with respect to x. dx. There's no dy, no y component. So then, what you're doing is integrating along the curve from, since this is dx, you're integrating, you're looking for the starting point at x and the end point at x. It's from 0 to 2. Based on the coordinates, it's from 0 to 2 of, let's multiply out the brackets. This would be 3x squared plus 3 ones 3 dx. So what you're looking at is the integral from 0 to 2 of, this would be, let's write it as 3x squared plus x plus 3 dx. So you see that. Now, here, you're ready to integrate. So we have 3x cubed over 3 plus x squared over 2 plus 3x. Remember your power rule, right? And it goes from 0 to 2. So here, 3 will cancel 3, right? Me, I can get some mosquitoes. These mosquitoes are plentiful nowadays, disturbing me. All right. So here now, 3 cancels 3. You put in the upper boundary. That's 2 cubed plus 2 squared over 2 plus 3 times 2 minus the lower boundary, which is 0 cubed plus 0 squared over 2 plus 3 times 0. And you know all of this will come to naught, to be 0. So 2 cubed, that's 8, plus 2 squared over 4, over 2 I mean, that's 2 plus 3, 2, 6. So what you have is 8 plus 2 is 10 plus 6 is 16. Alright? So the value, the answer is 16. Alright, so we'll be doing more examples in further videos. Alright, so I'll see you then.